Here. All right, so just to sort of timestamp this is essentially the first full meeting that we're having for the solar class here. So the first thing I want to do is pull up the schedule. Oh, I might sneeze here soon, so I apologize if I do. I'm just getting over a head cold here. I did send this out, but if you're we'll just review it just to let everybody know that what the schedule looks like. Course schedule and links. There we are. Too many files out here in the world. Hopefully this is the updated one, February 24th. Yep, March 3rd. All right. So yeah, just as a reminder, this week, today, March 3rd, we'll do a quick little review of chapters 1, 2, and 3. I don't feel like I have to do too much on this because chapters 1, 2, and 3 are pretty basic. They're mostly, review. They're formational. Yeah, they're important. You got to know this stuff, but it's not complicated. It's not hard. When we get into, say, chapters 5, 6, 7, now you start getting into some more difficult stuff. But so this one's pretty easy. So I thought I could spend a little time just looking at the structure of the course, how this is going to work. So chapters 1, 2, and 3, that's hopefully you're through those already. That's kind of just one of the purposes of these weekly meetings is to keep you on track. Am I ahead? Am I behind? It's not a thing you got to stick to. Like if I say we're doing 4 and 5 next week, if you want to do 6 and 7 too, that's fine. Or if you get a little bit behind, that's fine as well. But the idea is if you keep this pace, it's a pretty good pace that by the end of the course, you're not trying to cram 25 hours of study in the last 2 days. That's never good. Okay, so chapters 1, 2, and 3 are introduction, just background. Then we talk about solar cells and modules. Then we talk about the different types of systems. Next week, March 10th, we'll do chapters 4 and 5, which is basic electricity and parts of the PV system. And the concept there, we look at all the different component parts of a PV system, and then hopefully by the time you're done with that chapter, you'll understand what are the parts, what are their names, what is their function, and why would you pick one versus another? What are some of the features that are available? Like inverters have many, many different features. Why would you choose one feature, not another? So we give you a sense of it because there's always choices. And oftentimes the students will in their minds or in class, they'll say, hey, can we do this? If I want to do this, can we do this? And the answer is always yes, almost always yes. The question is, can you do it affordably? Is it realistic to do it and not spend so much money that it's not worth it? So almost everything in this world is possible if you've got enough money. Just maybe it's not practical. Then March 17th, we'll finish up chapter 5, get into chapter 6. And then the 24th, we'll do chapters 7, 8, and 9. There's where your brain's going to start to hurt a little bit. You're going to start feeling like you're getting so much information. I will reiterate that I don't think any of this stuff is hard, but there's a lot of information to absorb. So eventually your brain just feels like you're full. Sometimes you just have to do it several times before it makes sense because none of this was stuff that you were born knowing, and I remember when I was first doing this and I was studying grounding and bonding. And grounding and bonding is one of those concepts that they just keep impressing on you. This is very important. This is a life safety thing. This is a big deal. And I read 4 or 5 books on bonding and grounding. And I was just looking at this stuff going, I don't get this. I just don't understand what they're trying. I don't get it. And then you just get like this revelation. It's like, oh, so you're just hooking all the metal bits together and then giving it a place to go to the ground. Well, that's not hard. Why are you guys writing books about this? This doesn't make any sense. Just, yeah, okay, give it a clear pathway and get it to the ground in case electricity gets on a piece of metal that it doesn't belong on. So that's bonding and grounding, simple. So at some point it just all, it clicks. You never know quite when that is. And then the week of the week 6, that's March 31st, we just kind of do everything else. Everything that's, chapters 10, 11, 12, 13. You'll see as you get to the end of the book, the end of the chapters and everything, the last few chapters pretty short. You can do a bunch of them. And the reason why they're there is they're important, but they're not in depth because a lot of things like the paperwork, testing and commissioning, system maintenance and troubleshooting, those are for the level 2 people. Those are basically for the lead technician, the folks who have been involved in this for 5 years, 10 years, whatever. You need to be aware these things exist, but you're not going to be asked to do them. It's just not. The idea here is you're an entry level person. That's above your pay grade. So, and then I throw in 1 week just in case we have an interruption where we need to shift things. We've got a week to play with. Then we get into April 11th. April 11th is a Saturday. So the plan is we'll get together here in Marietta, Ohio, and we'll do the hands-on. So as part of this certification, there are 3 components that you have to complete in order to become certified in the world of solar through ETA. There's completing a 40-hour course that's been approved by ETA. Well, you're doing that as going through the online course. That's been approved and it meets the 40-hour requirement. Then you have to have performed certain hands-on tasks in front of a certified test administrator. Well, I'm a certified test administrator, and you're going to do those hands-on tasks on April 10th in Marietta, Ohio, between 8 a.m. and 4:30 p.m. And then you have to pass the examination. So those 3 things, the course, the hands-on, the exam. So on the 12th, which is Sunday, we'll get together at 8 o'clock in the morning again, and we'll spend 3 or 4 hours, depending on people's capacity, and we'll just review. We'll review everything. And then we'll have lunch, and then you'll take the test. And I think that works out best because it's always nice to have had a few hours to review everything just before you take the test. And then you're free to go. So if you're planning flights or drive time or whatever, normally we're going to be done by about 2:30 just on Sunday. So that's something to count on. I know, Corbin, you're only an hour away,
Yeah.
so that's not a big deal for you. But
Mhm.
so that's the plan. And anything about the structure or how this thing works, anything confusing there?
No, I thought the book was very well laid out, and
Mhm.
I thought it was very intuitive in how you present the information, and I thought you were explaining the subjects very well.
Mhm.
Because I tend to do a lot of research and reading whenever I get into a topic, and usually I read a lot of articles, and I found that you do it really well, how you present information, explain it, show images. It's very well done.
Thanks.
Mhm.
Thanks.
Yeah.
I'll expect an apple on my desk when you're all done, right?
Yeah.
Uh-huh.
I I would
Yeah,
yeah, I would back that up, Jay. Yeah, it's easy to follow. Go back, re-reference if you need to look things up. The videos correlate with it as well. So,
good.
um, that
Yeah,
yeah.
one of the reasons I got into doing this was, when I first started teaching solar, the material sucked. I mean, the training material was just horrible. Like I said, I struggled with trying to understand what these people are doing. And part of the problem is it's mostly written by engineers, and
Mhm.
engineers are terrible at communicating anything. So and then there's another interesting thing that happens, and maybe you'll notice this if I point it out to you. I didn't really notice it until I started writing textbooks, but there's a habit that some people have, which we refer to as skimming and diving when you're
Mhm.
writing. If I don't understand what I'm writing about, I skim over the surface and pretend like I covered
Mhm.
it. And if I really, really understand it, I dive so deep into it that nobody needs to know that much stuff, because I'm showing off now that I know everything there is to know about, standalone inverters or whatever. And so you get that if you're reading a book somewhere and you just think, well, why did they just sort of skim over that topic, but they're going into such depth about
Mhm.
this other thing that doesn't seem to be that important? Oftentimes the guy, did his graduation paper on that or something, and that's his pet thing about it. I want to talk about grounding and bonding because I know everything about it. So, and it's just curious. I just found it. I saw it when I was doing research after I noticed the concept. But I think the advantage that I have, and I'm sort of patting myself on the back here. I knew nothing about this when I started,
Mhm.
and I just assume nobody knows anything about it, because I find it very frustrating when you're reading something and they're making assumptions that you know something that you
Mhm.
just don't know. They throw out acronyms that just don't, I don't know what that even means. Why don't you just tell me what that means?
Mhm.
And I was listening to a podcast here today when I was walking, and they kept referring to how it was an economics thing on the stock market, and they kept saying, "Well, the SAS has gotten hammered. SAS has gotten hammered." And I kept going, "What the heck is SAS? I don't know what SAS is." And then I looked it up, and anyway, it's software as a service.
Mhm.
Okay, but I still don't even know what that means. It's like, okay, software as a service. Isn't all software a service? I mean, it's like, so clearly they have a concept of what it is, but I mean, yeah, I mean, it's something that makes things sound more complicated than they really are. So that's the purpose of all acronyms. Okay, so that said, let me grab the textbook here, and I'll just do a quick little summary of what I think within these first chapters is important. Now, if oh no, before I do that, let me share my screen, and I want to make sure that you or the people who are viewing this online are into the program properly and and able to do this. So I want to just let me share, and here we are. Okay, so can you guys see the solar PV training
Yeah.
Yeah.
homepage here? So if you go into solarpvtraining.com, you'll see a homepage that looks
Mhm.
something like this. And where we want you to jump into is the online courses. If you're not logged in, you're going to see that there's a price tag associated with these courses, but you should have access. So the thing you would do is go under and log in. It'll
Mhm.
bring up a window like that. Just log in. And at that point, it should throw you into the course. Just waiting on my computer here. Come on, internet, catch up. There we are. So it doesn't look much different. I don't know if you guys get this black line up here. I think I only get it because I'm the boss. It allows me to go into the dashboard and do a bunch of other stuff. So now it should show enrolled. When you're done, it'll show completed. And in order to access into this course, you just click either on the icon up here, the picture,
Mhm.
or you can click on continue study, and it'll throw you in. It's a little bit confusing because I've got the legacy version of the course right next to the current one. Hopefully you're not enrolled in both of them, but I've left the legacy one up there because we've got, probably 1,000 students who are still working through that. So I don't want to cancel them out just because we've updated everything. So anyway, so this brings you in. It should say
Oh,
2026 edition.
mhm.
and it'll bring you down. And when we talk about going into the course, chapter 1, Introduction to Photovoltaics, and when you complete a section, a green check mark should pop up, indicating that you completed it. When you completed the whole chapter, the green check mark should show up here. If it doesn't, don't worry too much. You can let me know. I can fix it manually if for some reason it didn't give you credit. Or you can go in and find out which thing didn't finish, and you can just look at it again. Oftentimes, where people run into it is say they're going to do the chapter review,
Mm-hmm.
even though they've gone through it, it doesn't consider you've completed it until you got an 80% on that chapter review. So you might want to do it several times just to get that. When you click on one of these things like government incentive programs, we changed in this version. We went away from there used to be slides that you advance through. Now it's all video. So you should be able to just click on it here to play it or click on the screen. It'll tell you what the amount of time is
Mm-hmm.
of this. So if you don't have enough time to get through that, you can bounce back out. Then there are also materials up here. So I know, Corbin, you had said you like to do other research. I'm trying to populate this with things that I think are helpful of the same subject matter. We talk about incentive programs. So here's a link to the Desire website that has all the different incentive programs. You'll click on that and it'll bring you in, and you can just do a deep dive into the incentive programs. This one, I don't know if it should load up with a picture. Come on. My internet's being very slow. Anyway, it'll take you into that. This is a nice site because you can really research and go state by state, finding out what's available, what's not. Other articles here, things like that. Now I'm still in the process of populating all the materials. So if you get further down into the course, hopefully I'll catch up and get them done before you get to them. But if I don't, yeah, there may be some disconnects. There may not be as much as I would want to be there. But once you've clicked, another thing that you can do here is if you run into a question as you're doing this, there is this little AI bot down here that you can just simply type in, and it's supposed to have referenced stuff from this course. But I might say what incentive programs are available for solar in Massachusetts. I'm going to spell it wrong. Massachusetts. Two T's, is that right?
Two T's, yeah.
Yep. And in theory, it should come up with some stuff. So it's just there as a convenient interaction point to query. You probably have AI tools available to you elsewhere, but this
Mm-hmm.
just happens to be right there. Let's see if it actually, what did it do? It didn't. Now you guys are making me look bad. Huh. Let's see if I gave it too hard a question.
Or just do MA instead of Massachusetts. Who knows? I haven't spelled it out too much yet.
Yeah, maybe this
'Cause I know
uses
they
it
have
uses
programs called
ChatGPT.
Mouse Save.
Yeah. Well, I know it's charging me for stuff, so that's weird. I'll have to look into it. I thought that was all.
That's spelled right.
Yeah.
So,
No, it's chugging and it's thinking, but it's just not working here. All right, I'll have to go in and see. Anyway, really good feature. Very helpful, right? So here
In any new industry,
you'll just hear my
you see
voice.
the government try and come up with some incentive programs.
If you want to mute it, but that's Nascent industry, one that's just starting out, to something that can be competitive with the established competition. That's the same that's been happening here in the solar. So hopefully there haven't been any problems for you guys. I'm assuming you've been into this and you haven't had any problems, but this will just walk you through it. It's a very passive process. And then when you're done, it'll give you the option to jump to the next and the next and the next.
One,
So, yeah.
one question, Jay. The online NEC reference tool, I
Uh-huh.
saw that's good for 14 days, and that'll take us through whatever we need to for the rest of the class.
Yeah, the only time you use it is during this lab.
Oh,
Yeah, so if you need to use the NEC, um, it's not, you won't need it as a reference guide for the rest of this class,
okay.
but it's good to have if you're doing this as a career. If you're just curious, I mostly just wanted to use it so that if you ever did have to look something up, you were familiar with its structure, with its format.
Okay.
Um, but you can use AI out there anymore, and it's pirated the NEC. And if you just say, what does NEC Article 690.15 say, it'll spit it out.
Mhm.
Or I just did a query for it earlier where I said, which articles in the NEC reference rapid shutdown concerns for batteries and solar systems, and it gave me a whole list of all the specific references, which is normally it would have taken me 10 minutes to go through the NEC and
Mhm.
look under indexes and try and figure that out. So yeah, they're getting pirated. So here, if you're taking the quiz, it'll give you the question, converting the energy from sun. Well, hopefully you know that's photovoltaic. And after you've selected it, you hit check
Mhm.
and it'll give you the correct and so on. Now, a lot of these things um, have more information. I've tried, especially when we get into the electrical. Um, if there's something like if it says what is resistance or whatever, then I might include a video about resistance that's in the answer, and you can just look at that. There's a lot of things in the materials in those videos, not really part of the course, but it's just good information.
Mhm.
And feel free to wander through. One of my goals, this is sort of the first step in that, but ultimately my goal, this tell you a little my philosophy of education, is I think our educational system is pretty bad,
Yeah.
and it hasn't changed that much since Abraham Lincoln was a kid. I mean, basically, you get the sage on the stage who says, I know everything. I'm going to stand up here. I'm going to tell you what things are. And then you're going to parrot it back at me in the form of a test. And I'm going to give you a grade based on how well you can regurgitate the things I just said to you. And that's our educational system in a nutshell. Whether you go through elementary school or you get your PhD, it's mostly just parroting back whatever they decided you needed to regurgitate. I would rather see that these courses, now that we have the advent of AI as a tool, allow you to wander, but keep redirecting you back to the things that are important for you to understand, you know, um, so that it keeps nudging you. It's sort of like, I don't know if you play video games or something, but the video game experience
Mhm.
is different for every person who does the game because they go down different pathways and they do different things. Um, but there's an overall theme that you get to the end and you've won the game. Well, you've got to have checked off all these things before you can finish. You can wander and meander and go down cul-de-sacs and go deeper into things and whatever your interest is, but there's still a core amount of information you still need to somehow get. And I would rather that be done circularly, wandering, as opposed to linear. So that's kind of where I hope all this gets eventually. We're moving slowly that way, but it still is following a linear process.
Mhm.
You go through chapter one, then two, then three, then four, and so on and so forth. But you know, it'll catch up eventually. Any questions about the way this works here?
No, it actually reminds me of a lot of school programs that I use that I like. It's Khan Academy. It reminds me of
Uh-huh.
how that's structured a
Yeah.
lot. So I really like Khan Academy, so I really liked how this was structured too.
Mhm.
Okay, good. All right. Well, if you have any problems, you've got my email. That's usually the best way to get a hold of me is to to go ahead and just send me an email that I have this problem, I can't get into it, it's locked up. Or, for example, if you just tried using the AI and you say, hey, it's not responding, send me an email and I'll go in and see if I can figure it out. Um, like I said, I thought I had that fixed. Somebody sent me a note saying, hey, it keeps telling me that it needs money before it's going to answer my question. So so I went in and I was like, oh, okay, well, I gave it a credit card. That should have got fixed. It was one of those situations where they say, we'll let you use it free for a while just to see if you like it. And apparently I used up whatever quota of free that they decided I was allowed to have. So
Mhm.
so I did give them money and now they don't work at all. So all right. Okay, so in the book, Introduction to Photovoltaics, it really just gives you some background.
Yeah.
Like I said, pretty straightforward. The utility demand curve. If you really want to get into some deep diving stuff, deeper into a subject, use the resource that's on solar PV training under that top menu where online courses. There's a thing called Solar Noon Tuesday. That's
Mhm.
your menu option, and that we have. And you're welcome to join us. It's at noon on Tuesday, just before these sessions. And we do a deep dive on a subject every week, and all of those are recorded. So there's like 4 years of material there. So some of them very interesting. So you can
Mhm.
just sort of wander through those and see what you like. So I think chapter one, pretty self-explanatory, gives you a little bit of foundation, a little bit of history. Chapter two, we talk about solar cells, solar panels. I
Mhm.
don't really want to get into the workings of solar. It's fair enough to just say it's magic. You put a glass sheet out in the sun and you get electricity. I mean, that's just magic. As far as an installer, I'm more interested that you understand what you don't do so you don't get hurt. I
Mhm.
don't care if you understand the photovoltaic effect and how photons go through the band gap and all of that. It's
Mhm.
more, what are we doing with this? So, the concept of what is a cell, what is a panel, what is a module, what is an array, I think that's discussed there. Some of the new technologies, we're kind of in this mode at the moment where technologies are changing. So, um, a lot of students, when they first come into this, they like to focus on the efficiency of a panel, thinking, okay, if it's 25% efficient, that's better than if it's 23% efficient. That must be a better panel. I don't really care what the efficiency is. The question is, how much does it cost for every watt that it delivers? You know, if I've got a panel that's 30% efficient and it costs more than twice as much as a panel that's 15% efficient, it's not a great deal. It's really what is the price per watt of generated electricity. The only time efficiency comes into play is if you have a limited space. So if you have a roof that can only handle 10 panels, well, then to maximize your production, you want to have as efficient a panel as possible. But if you're not limited for space, then the efficiency of a panel just doesn't matter. So that's something to just sort of bear in mind. We're talking bifacial panels are becoming a thing. Panels that generate power from above and below.
Mhm.
So you could imagine situations where that would be helpful. If you
Mhm.
have a rack out in the middle of a beach with light reflecting off of the beach or a snowfield or next to a lake where light can reflect off the ground as well as come from up above. But if you're sticking it on a roof and it's only 3 inches off the deck of the roof, bidirectional doesn't do you much good. So, those kind of things. Um, we're in the, we're in a bit of a transition. The main panel that we deal with is silicon based. So there's either monocrystalline or polycrystalline.
Mhm.
It's either, a single crystal made into a solar cell, or it's a slurry of crystals that they just sort of harden up and cut into a solar cell. Not a lot of difference between the two. But then there's also thin film technology. In the United States, most of the utility scale solar, the stuff that you would see along highways, with big tracking arms that are, the big, huge systems that all the people are throwing signs out saying no solar on prime farmland, and they get all bent out of shape about it. Those are normally thin film cells. They're
Mm.
not crystalline. And the reason for that, there are a number of reasons, but it's another technology. And there are different flavors of that as well. You don't have to get too deep into it. Just understand these things exist. There are slight differences to what you would buy, what you would put in. And that's covered pretty well, I think, in
Mhm.
chapter 2. The one thing that's a little bit confusing in chapter 2, and let me see if I can, if this thing has a whiteboard. Um, okay, can you see my whiteboard here? Do you guys see the whiteboard?
It is loading. Oh,
Yes.
okay, now it's
Yes. Now it
All right.
is. There.
Yeah, this is
Yeah.
a concept that some people have struggle with, and it's really important that you understand. The idea of an IV curve. So this is an IV curve. IV just stands for amps and volts. And every solar panel will have an IV curve that looks something, in the neighborhood of this. So what does that mean? Well, this is amps over here. It's a plot, and this is volts, and this is going to be zero axis.
Mhm.
It just says that for every point, amps times volts equals watts. So this curve is showing you watts. So when you multiply amps times volts, you get watts. Well, if we start out, what is the maximum amps that this panel could ever produce? And this IV curve that they always give you as a reference in your spec sheet is at standard test conditions, because there's an infinite number of curves. So it's like, under what conditions are we measuring this?
Mhm.
And standard test conditions is going to be 1,000 watts per square meter of irradiance, right? It's going to be 25 degrees Celsius. So temperature and sunlight are big
Mhm.
issues. And then the other one is 1.5 atmospheres. It's kind of thrown in there. Nobody really cares. It's basically sea level at in the upper latitudes. Um, okay, so that's basically, we're worried about how much sunlight. So what this represents, standard test conditions, is basically on a clear sunny day at sea level when the temperature is about 77 degrees Fahrenheit, this is what we're measuring. And we just needed to compare apples to apples, so we picked this as our reference point. It could have been anything, but as long as everybody agrees, now this 400-watt panel is going to be the same as that 400-watt panel. Why? Because we measured them under the same conditions, you know? So it's just a gentleman's agreement,
Okay.
right? So it turns out that the behavior of a panel, as we increase the voltage, is always going to give you a watt range that looks something like this. So the maximum amps that panel would ever produce under standard test conditions is going to be found right at this point. And that point is known as the ISC. The ISC is the amp short circuit, or the maximum theoretical amps. The maximum theoretical voltage that panel might ever produce under standard test conditions is down here on this point, and that's known as the
Mhm.
VOC. Now, the VOC we can actually measure. And if you stuck a meter into a panel that wasn't hooked up to anything, you're going to be measuring VOC. So whatever it's generating in volts, you're generating it, and you're measuring it. The water analogy is really helpful here. Think of volts like water pressure, and amps like the amount of the size of the pipe, the amount of flow through the pipe, right? So if I increase the pressure and decrease the size of the pipe, I might get the same amount of water flowing through as if I had a big pipe under low pressure. So it's always a combination of
Mhm.
the two that measures the amount of water flowing, which is watts. So that's the concept. The bigger the pipe, the more the amps, the higher the pressure, the more the volts. And everything is always a combination of both. So these are the maximum theoretical amps. I cannot measure ISC because if the voltage is zero, if there's no water flowing, you can't measure current
Mhm.
because current is basically the flow of water or the flow of electricity. If nothing's flowing, can't measure it. But I can measure volts just like I can measure water pressure even if no water is flowing. It's just I can put a gauge on that pipe and figure out what pressure it's under. All right, so as we move through this here, at some point there's going to be a maximum amount of water or maximum amount of electricity, and it usually falls somewhere in this curve. And if you think about it, if we were to put numbers here, let's say that's 5, 10, 15, 20, 25, 30, 35, and this is 1 amp, 2 amps, 3 amps, 4 amps, 5, and 6. All right, so how many watts? Well, 6 times 0 is 0, so nothing here at ISC. If I move out to here, now it's going to be 5 times 6, about 30, so about 30 watts. If I move out to 15, it's still going to be pretty close to 6. 15 times 6 is going to be 90 watts. And I keep coming out here, 20 times 5, that's going to be 100 watts. Come out here to 25 times a little more than 4. Let's just say that's 110. And then I come here to 30, and it's 30 times 2.5. So that's going to be 70. So notice it goes up, it goes up, it goes up, it hits a maximum point, and then it starts going down. So the analogy there I like to use is think about it like you're measuring traffic through an intersection. And as you add more and more cars, you're going to get more and more traffic flowing through that intersection until you've added so many cars that they start to interfere with each other. Somebody taps the brake, somebody slows down, somebody, not paying attention. And all of a sudden, at some point, adding more cars actually means less are flowing through that intersection until you get down here to VOC, and that's complete 100% gridlock. Nobody's moving because you've just added so much stuff in there that the internal resistance, the internal interference, causes there to be no flow of electricity. Because VOC, you're generating zero power. ISC, you're generating zero power. Somewhere along this line, let's just say it's right here, that's the maximum power point. So we call that MPP or Pmax. They haven't really standardized on an acronym, but either way, that's the maximum power point. And then there is a voltage associated with that, and there is an amperage associated with that. The amperage is the Imax, the amps at the maximum power point, and the voltage is the Vmax, or the voltage at the maximum power point. Right? So these are the 5 places on the IV curve that the solar panel manufacturer is going to give you. And they're important for you to understand what they are. The MPP, the maximum power point, that's just the under standard test conditions. Ideally, that's the most power that thing can produce. And if you're referring to it as a 400 watt panel, it's 400 watts at the maximum power point under standard test conditions. So that's what they're referring to. Everything's perfect and it's under standard test conditions. Now, why are we given all 4 of these numbers? Well, we use the ISC and the VOC, which are the theoretical maximums, we use those numbers when we're designing our system because they're the worst case scenario. They're the most this thing. Now, ideally, they're never going to happen because if they did, the system wasn't working. But we're just going to use them as the worst case scenario. So this is the upper voltage that we're going to use when we plug in trying to design our system to live within certain voltage limits. And the amps, we're going to use that number when we start sizing the wire so we don't overload our wire and cause it to catch on fire. So these are two design criteria numbers. And then what is the Imax? What is the Vmax? Well, those are the voltage and the amperage that it should be operating in at the real and in the real world when it's functioning at its maximum power point. So those are sort of our operational numbers. If I'm trying to figure out amps or I'm trying to figure out volts, what are they actually doing? So I use Imax or IMP, Vmax or VMP, and I'm going to use those numbers. The other ones I'm going to use when I'm designing. Clear as mud?
Yes,
Yeah.
I understand before, but when you explained it now, it's a bit more clearer.
Good.
But I understand it before. Thank you for
Okay.
teaching.
Good. All right. So let me see. I know there's a way I can quick erase this. Nope. I want to. All right. I think I can I just want to. There we go. All right. So if this, now I got to relearn all of these things. That's the eraser. Where's the pencil? Huh. All right. There we go. All right. So one of the things, nope, that's not it. Uh, Anybody know what that's the eraser. Here's the pencil. That's highlighter. That's the pen. All right. So one of the things I said is there's an infinite number of IV curves. So this was the IV curve under standard test conditions. Let's say that a cloud passes over the sun. Amperage is affected by irradiance, and irradiance is how much sunlight is hitting the panel. So if a cloud passes over, maybe my curve changes to look something like that. It affects mostly amps, a little bit of voltage, but mostly amps. Now all of a sudden, it gets even darker. Well, I might have a curve like that. What happens if it gets colder? Well, electricity voltage likes the cold. So if it got colder, my curve may change to this. If it got hotter, that affects voltage, so it might curve like that. And in the meantime, that maximum power point, notice, is jumping all over the place, just as the conditions are changing. So there is a device that's attached to the first piece of electronics that connects to your panel, and it's called the MPPT, the maximum power point tracking device. And what that does is on a millisecond by millisecond basis, it's going to adjust the panel to always operate at the maximum power point. So it's going to keep shifting things around so that the panel may not be producing the most power it's capable of producing, but it's going to produce the most power it's capable of producing under the conditions it's currently facing, right? So that's going to change depending on temperature and irradiance, mostly. So that's what the MPPT does, is it's constantly making sure that your panel is producing at the sweet spot. Is that clear?
Actually, I have a question. So, where would you find this MPPT at? Like on the array at Brew Rock Station, where could you find this physically or?
Yes. Yes. Well, you wouldn't find it, but it's contained within each one of the microinverters. So
Oh,
every
okay.
single microinverter has its own MPPT. And that's one of the great things about a microinverter is you can, let's say I've got a solar array like this, like the one at Blue Rock Station,
Mhm.
and I've got, yeah, we'll just say, how many is that? 12 panels. All right. If I did a string inverter, I just have a string inverter here, and there would be one MPPT. So the MPPT is going to be in the inverter. It's always in the first electronic device that connects to the panel. And if I was wiring these guys together in a string, and I go from negative to negative positive, so I'm hooking all these panels together like this, and then it comes down and it's going to hook into my inverter. So all of these panels now behave as a unit, and they're all connected to just one MPPT. Well, what would happen if all of a sudden this panel over here gets shaded? A little bit of shade over
Mhm.
here, it affects them all because they all function like their own thing. Okay? Make sense?
Yes.
So if I've lost some of my power from one panel just because one panel shaded, it affected every single one. But the nice thing about the microinverters is there is no single. There's an inverter here and an inverter here and one here and one here, and there's one on every single panel. So then the output is all connected together. So all these microinverters are connected together. So my string of, it's actually called a branch circuit, would connect all of these guys together. And then it would go not to an inverter because these are all inverters, but it would go to an AC disconnect to turn it off. And then it would go to your service panel like that. Well, if this same shading took place, let's say it took place here, it would affect the output of this panel, a little bit of the output of this panel, but none of the other panels are going to get affected because the MPPT is on each single panel. So each single panel is going to produce to its maximum. So that's one reason why you use microinverters or any module level power electronic, MLPE, is it has an MPPT on every single panel. And as you get into it, you're going to find that can be a big deal, a really big deal. I've got an illustration in the book somewhere from the thing at Blue Rock Station that really just shows shading on one little panel reduced the output of that panel by 90%. You know, so if they were all hooked together, shading on one panel might cut your entire array's energy production by 90%. You know, but if you isolate it to a single panel, okay, that panel is affected, but none of the other ones are. Another nice thing about microinverters is let's say this microinverter fails, it just breaks, it just dies. All the rest are still functioning. But
Mhm.
if I have a string inverter where everything's feeding into that string inverter and something happens to that string inverter, then the entire array is no longer functioning because there's a single point of failure. So that's one of the advantages. All right. Any other questions? Because I've run up to the hour here. Any questions about chapters 1, 2, or 3?
No.
All right. Okay, great. Okay, so we'll call it there. I'll just tell you that if you do have questions throughout the week, send me an email, j@solarpvtraining.com, and we'll get those answered. And if there are any concerns or any problems with the course, and then we'll get together at this time next week. Invite you guys to be on Solar Noon if you've got the time. Then you'll know if I run late where I am, and and then we'll do this again next week. All right.
Okay. Well, thank
Okay.
you, Jeff.
Sure thing. Take care.
Yep.
Bye bye.